All right, guys. So, what we're going to be talking about today in these notes is how we can use a graphing calculator in order to graph quadratic equations, as well as how we can write quadratic equations using a graph. So that's why I've got the different set of notes up. Notice that we are going to be using our graphing calculators today. And while it is possible to use the Desmos graphing calculator to graph any of these, obviously it is still important to know how to use your own graphing calculator because there are some things that it can do that your Desmos calculator cannot, as well as the fact that you can only use this type of calculator on the ACT and SAT exams. So especially on those exams and on the ACT, there's quite a bit about quadratics on that exam. It's going to be important to know how to use your graphing calculator and how to use it quickly. Obviously, Desmos is much easier to use, but graphing calculator is still something you need to know how to work with. So that's going to be what we're going to talk about in today's notes. Is going to be the first part about using your graphing calculator, and then the second part is going to be how to write equations based on a graph. So that being said, let's take a look at some example problems. We're going to look at basically 4 examples of how to use your graphing calculator, and then we will start to talk about writing equations from a graph. So for each of these different equations, we're going to use our graphing calculator to find the maximum or minimum point, which is the vertex, as well as to find the x-intercepts and y-intercept of our graph. We're then going to draw a simple sketch of those, of our graph, labeling those points. So for number 1, we're going to graph the function f of x is equal to x squared plus 7x plus 10. In order to do that, you need to first hit the y equals button on your graphing calculator. Now, I've already got some other equations in here, and that is simply because these are going to be our equations for numbers 2, 3, and 4. If you already have other equations in there, I would recommend clearing those out. Or just like I did, going over to the equal sign and turning those off for the other equations. But probably the best thing to do would be to clear any other equations out of your graphing calculator. A lot of times when you end up with an error message, it's because you left something in there that needed to be cleared. So now, to type in number 1, x squared plus 7x plus 10, make sure that you're using the x button, which is next to alpha. It actually has some other variables after it. It has t, theta, and n. We're going to use it for x. And then there is a squared button right here to use. Remember, you can also use the caret button, and then the 2 if you prefer to type it in that way. But x squared plus 7x plus 10 is the first equation that we'll be using. So let's go ahead and graph that. Before we actually hit graph, guys, it would be also a good idea to make sure that these plots are all turned off. And then once you've done that, before we hit graph, I would recommend hitting this zoom button and then choosing option 6, which is zoom standard. That'll just make sure that we start in a 10 by 10 viewing window, just kind of the standard viewing window for a quadratic. So we should now see what our quadratic looks like. We could go ahead and draw a simple sketch, but let's wait to get some points before we do that, just so we can label everything. Let's start by finding the vertex. In order to find the vertex, we're going to use the calc menu of the calculator, which is right above this trace button. So if you hit second and then trace, so second calc, we're going to choose the option for minimum. And again, it's important to make sure you pick the correct one. If you try to do maximum, it's not going to work. And in this case, because our graph had a minimum point down here at the bottom, we need to make sure we selected minimum. Your graphing calculator is then going to ask you for what's called a left bound or a left boundary. What you need to do using the left and right arrows is move your flashing cursor somewhere to the left of your vertex and press enter. What that's going to do is set up a left boundary for your calculator so that your calculator knows that the vertex is somewhere to the right of that left boundary. We're then going to do the same thing on the other side and set a right boundary. So once again, using the left and right cursor, we're going to move our cursor somewhere to the right of our vertex and press enter. Finally, it's going to ask you to guess. And so when it asks you to guess, we're going to try to get as close to where it looks like that vertex is as possible and press enter one last time. And it's going to give us our point for our vertex. So it looks like in this case, our vertex is at the point negative 3.5 and negative 2.25. And then we already knew that it was a minimum, so I'll go ahead and circle that. Next, let's go ahead and find our x-intercepts. And we're going to do that kind of in the same way that we just did the vertex. So we're going to start by going to the calc menu once again, so second and then calc. This time we're going to choose the option for 0, not intersect. Be careful that you're not choosing intersect. That is not the same as intercept. Remember, intersect is where you are able to calculate the point of intersection between two different lines. In this case, we just want to know what the zeros are. So when we press enter to find our zeros, it's going to ask us for basically the same three things. It's going to ask us first for a left bound. So we're going to move our cursor somewhere to the left of one of our zeros. In this case, I'm going to do this 0 on the left-hand side. We're then going to be asked for a right bound. So once again, move our cursor somewhere to the right and press enter. Finally, we're going to guess where that 0 is and press enter. And it turns out that that x-intercept is at -5, 0. Now there's also another x-intercept, so let's do it again. Second calc, option 2 for 0. Again, we need a left bound, so somewhere to the left of our x-intercept. Then move it somewhere to the right of our x-intercept for the right bound. And then go ahead and press enter to guess where it looks like that is. And it turns out that that is at -2, 0. Finally, we need to find our y-intercept. There is not a button to type to get there. All we need to do in order to find that y-intercept is to hit this trace button and then to type in the x value, which remember the x value for y-intercept is always 0. Press enter and it will tell us that the y-intercept is at 0, 10. And now we are ready to draw in our sketch. So when we draw in our sketch, probably the easiest way to do that is to draw in what the graph looks like as best you can. So something kind of like this. And then to simply label each of those points. So we just found our y-intercept was at 0, 10. We knew that this x-intercept was at -2, 0. We knew that this x-intercept was at -5, 0. And that this x-intercept is at -3.5 and -2.25. If you prefer not to label all of those points like I just did, just draw the tick marks on your axes and then make sure that the points are graphed as accurately as possible. So you can either use tick marks or just label each of the individual points. Okay, let's go ahead and take a look at number 2. So number 2, I'm going to go back to y equals. I'm going to go ahead and clear out our first equation that we had. And like I said, I've already got this one typed in, so I just need to turn the equal sign on. Make sure, guys, too, that when you type this in that you're using the negative button down here for the start of it. Please, please, please do not try to use this minus sign. If you try to use this minus sign and hit graph, it's going to tell you that there's a syntax error. What that means, if I hit go to, is that this minus sign needs to be a negative sign. So make sure that you're using negative signs anywhere that you're putting it in front of a variable. And now we should be ready to go ahead and hit graph for that second equation. All right, so let's go ahead and start by finding our vertex. Once again, remember that our vertex is, in this case, going to be a maximum. So when we hit second and then calc, we need to choose option 4 for maximum instead of option 3 for minimum. But then the commands are going to be the exact same, so it's going to ask us for a left bound, and then for a right bound, and then to guess. And then when we are done with that, it's going to give us a point, which is very, very, very close to 1. In fact, if you look at your x value, 0.99999, and then some other decimals, really what that is just a little bit of a round-off error. That really actually is the 0.1, 4. So if you do get a decimal like that, round it up to a whole number like 1. And again, we already knew that that was a maximum, but we'll go ahead and circle that. Let's go ahead and find our x-intercepts. In order to save time, if your x-intercepts look like they're going to be at whole numbers, you might try to use trace instead of using the calc menu. For example, it looks like this x-intercept is really close to -1. So if I hit trace and type in -1, it does in fact give me -1, 0. And so that is going to be one of our x-intercepts. So if it's a whole number, you can save a little bit of time by trying to guess what those are. And then it looks like the other one might be at 3, 0. So let's go ahead and type in 3 and see if it takes us to 0. And it does. So then there would be our 2 x-intercepts. If they don't give you 0, or if you guess and it's not right, then you're going to still have to use that x-intercept from the 0 function from second calc. Now remember, for y-intercept, that's always where x is equal to 0. So if I type in 0 for x, that's going to be at 0, 3. So that would be our y-intercept. So in this case, it might actually be easiest to go ahead and use tick marks to draw this in. So we had a vertex at 1, 4. We had an x-intercept at -1, 0, as well as at 3, 0. And then we had a y-intercept at 0, 3. So our graph looks something kind of like this. If we can get it to go through, come on now. Oh, there we go. Cool. So yeah, in this case, tick marks might be a little bit easier to use just because they all ended up being whole numbers and pretty close to one another. All right, so let's take a look at a couple more, and then we will be done with this first part of today's notes. So for our next one, let's go back to our y equals menu. We're now going to clear out our second equation and type in our third equation. And again, that's going to be negative x squared, so make sure the negative sign is there, plus 4x minus 4. And so for the minus 4, you do actually want to use a minus sign there instead of a negative. But let's go ahead and turn that on, and then we'll take a look at its graph. All right, so we should be ready to graph that now. Here is our equation. And we should be ready to go ahead and find vertex, max, min, x-intercepts, and y-intercept. So let's start with our vertex. So once again, we know that this is going to be a maximum, so we'll hit second calc, choose option number 4 for maximum, and run through each of those commands. So left bound, again, somewhere to the left of our 0. Right bound, somewhere to the right of our 0. Make sure to press enter after each of those, and then we will choose our point as close to our vertex as possible. And so now we actually have a couple things to talk about. The first, that 1.999, we're going to go ahead and round up to be 2. The second part, this -4.9 e -12, is scientific notation for -4 multiplied by 10 to the -12th. As a decimal, what that ends up being, you move your decimal 12 places to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 4, and then 9. In other words, that number is a number very, very, very close to 0. And in fact, that number should be 0. So 2, 0 should be our should be our vertex. And so it's important to make sure that you understand kind of the decimals that your calculator gives you, making sure that you round those up to a number if needed, or down to 0 if they give you that sort of notation. Okay, so our vertex is going to be at 2, 0. That also is a maximum, so I'm going to go ahead and circle that. It also happens to be our x-intercepts. Notice that that is an x-intercept at 2, 0, and so actually we don't even have to calculate those. The only thing we have left to find is our y-intercept. In order to find that, remember to hit the trace button, type in the x value of 0, and that tells you that our y-intercept is at 0, -4. Once again, since these are fairly small numbers and pretty close to one another, I'm going to go ahead and just use tick marks to label my graph. So we've got our vertex at 2, 0, y-intercept at -4, 0, and then we will just draw in a sketch of our graph using those points. So again, these graphs are not going to be super accurate, but they're just trying to give you an idea of what the quadratic looks like. All right, one last example to look at. We've got k of x equal to x squared plus 3x. So let's go back into y equals. We're going to go ahead and get rid of that most recent equation and type in our last equation, so x squared plus 3x. And once we are done with that, we should be ready to go ahead and hit graph. So here is what that graph looks like. So in this case, for our vertex, we're going to be calculating a minimum. So second calc, we'll choose option number 3 for minimum. And let's go ahead and see what that value is. Well, for left bound, we'll go to the left and press enter. Right bound to the right and press enter. And then we will guess as close to that 0 as possible. And that's going to be at -1.5 and -2.25. So -1.5, -2.25. And again, we already knew that was a minimum. Once again, for x-intercepts, I'm just going to guess at those and hope that we are able to find those. So I'm going to hit trace. It looks like one of them is at -3, and in fact it is. So -3, 0 would be one of our x-intercepts. The other almost looks like it's at 0, 0. So let me hit trace. Let's type in 0 for x, and it does in fact end up being at 0, 0, which means that it is also our y-intercept, because we would have done the same thing for our y-intercept. We would have typed in 0 for x. In this case, because of decimals, I'm just going to draw in my graph and then label those points. So here's what that graph looked like. We've got our 1 x-intercept, which is also the y-intercept, 0, 0. We've got a point over here for the x-intercept on the left of -3, 0. And then we've got our vertex at -1.5 and -2.25. All right. So guys, we're now ready to move on to the second part of today's notes, where we're going to be talking about how to write equations based on a graph. In order to do that, let's first review kind of what each form of an equation looks like, starting with factored, which was the first one that we saw. For an equation in factored form, it's written as follows. Y is equal to a parentheses x minus b parentheses x minus c. Well, remember that b and c are your x-intercepts of your graph. And then a is any stretch, compression, or reflection based on transformations. For your vertex, remember that the vertex is of the form y is equal to a, and then we use some special letters, x minus h squared plus k, where h comma k is our vertex. And then standard form is of the form y equals ax squared plus bx plus c. That was the last form that we looked at. So here's kind of our step-by-step for writing equations from a graph. Step number one is we're going to copy down the formula for either factored or vertex form. So you're going to start with either factored or vertex, and it doesn't matter which one you prefer. Step number two, you're going to fill in the vertex or the x-intercepts depending on which form you pick. So if you pick vertex form, obviously you're filling in the vertex. Factored form, obviously you're filling in the two x-intercepts. Step number three, you're going to pick another point on the graph and plug that in for x and y. Oftentimes that's the y-intercept, but it doesn't have to be. Step number four, you're going to solve for a. So a is really kind of the one thing you're not going to know just by looking at the graph. You're going to have to do a little bit of solving to find that. And once you have a, though, you should have everything you need to, in step 5, write your final equation, leaving x and y as variables. Step number 6, we're going to use that same a value in the other form. So whichever form we didn't pick, so if we started with factored, we'll use a in vertex form and write that equation, or vice versa. And I'll show it once both ways. And then for step 7, we're going to find standard form by multiplying out either factored or vertex form. Factored form is usually a little bit easier, but it's up to you, whichever one you prefer. So let's take a look at some examples. For this first example for number 5, I'm going to actually start with factored form, then write my vertex form, then go to standard form. In number 6, I'll start with vertex and then go factored and then standard. So for factored form, step 1, we're going to just write out what the basic equation looks like. So that was a parentheses x minus b parentheses x minus c. Remember, b is your x-intercept and c is your other x-intercept. So to write those in, we would write y is equal to a parentheses x minus a -4 for b. So that becomes x plus 4. And then x minus 2 for c. Now we need to pick another point on our graph. I'm going to go ahead and pick this point of 0, -8. We're going to put 0 in for x and -8 in for y. So what that looks like is -8 is equal to a, parentheses 0 plus 4, parentheses 0 minus 2. Now we've got something which we can solve to try to get a by itself. So let's go ahead and simplify what we had in the parentheses. 0 plus 4 is 4. 0 minus 2 is -2. And now we can keep simplifying. So on the right side, 4 multiplied by -2 is -8. So now we've got that -8 is equal to -8 multiplied by a. So to get a by itself, we just divide each side by -8. And it turns out that a is equal to 1. So actually our equation, pretty basic. We have y is equal to 1 parentheses x plus 4. Parentheses x minus 2. So in other words, we're putting a into this equation right here. And really, since it's a 1, we don't even need to put it there. I'll just leave it like that. And here would be our factored form. That makes all the other forms go kind of nicely. So for vertex, we're going to have y equals a parentheses x minus h squared plus k. So to write those in, we have y is equal to, we now know that a is 1. Remember that h is the x value for your vertex, k is the y value. So you'd have x minus a negative 1, so x plus 1 squared minus 9 for k, and here would be your vertex form for this graph. Finally, for standard form, we just pick either factored or vertex and multiply it out. I'm going to go ahead and pick our factored form, so x plus 4 and x plus 2. And we just now distribute everything out, so x multiplied by x is x squared, multiplied by 2 is 2x, and then 4 multiplied by x is 4x, multiplied by 2 is 8. So now we just need to simplify x squared plus 6x plus 8, and here is standard form. And so if you want to check yourself, obviously you could put that into your graphing calculator, make sure that it looks the same as the graph you were given. It would also be good to make sure that each of these forms actually are equal to each other, because if they aren't, then we know we messed up somewhere. All right, let's take one last look at this next example. So we're going to look for our a value, hopefully going to be something other than 1, because 1's kind of not very exciting. And in fact, since our graph opened up, we already knew that a had to be greater than 0. So on number 6, we already know that it's at least not going to be 1. Because our graph is opening down, we already should know that a is going to be less than 0. It's going to be a negative number of some kind. And let's go ahead and work this one a little bit differently. So let's start with vertex form this time, and then we'll do factored, and then we'll do standard last. So standard always comes last, and you really always get standard from one of the other two forms. You can in fact start with standard, but it's very, very difficult. Something that I would need to show you during seminar one day if you were interested in seeing how to do that. So for vertex form, we're going to start by copying down our basic setup for that. So a parentheses x minus h squared plus k. Remember that h and k are the values for your vertex. So let's go ahead and fill those in. We're going to have x minus a negative 3, so x plus 3 squared, plus our k value, so plus 8. Since we don't know what a is, let's go ahead and plug in one of our other points. Let's go ahead, I'm going to use the y-intercept once again at 0, negative 10. So we'll put negative 10 in for y is equal to a parentheses, 0 goes in for x, plus 3 squared, plus 8. So let's go ahead and solve this equation for a. So on the right side, we've got some simplifying we can do. 0 plus 3 is 3 squared, plus 8, which 3 squared is 9. So now here's the equation we need to solve. So let's go ahead and subtract 8 from both sides. So negative 18 is equal to 9a. And now to get a by itself, just divide each side by 9, and you'll get that negative 2 is our a value. All right, which should make sense because that would be less than 0. That means that our graph opens down. Also, 2 is greater than 1, so that would mean that this should be a vertical stretch, and that does in fact look like what's happened. The graph does look narrow, so a vertical stretch does make sense. So now let's take this equation where we had almost everything already. Go ahead and plug in our a value. Everything else stays the same, and here is our vertex form. So for factored form, let's go ahead and find that next. Remember that that is y is equal to a, x minus b, x minus c. Well, remember, b is your first x-intercept, c is the second, and it doesn't really matter which order you put those in. So then that would become y is equal to, we now know a is negative 2 from our work in the vertex form, and then x minus b, x minus a negative 5 is x plus 5, x minus c is x minus negative 1, so x plus 1. And then here would be our factored form. All right, so my recommendation would be to multiply out factored form to get standard form. If you want to multiply out vertex, you would need to write x plus 3 squared out first and multiply it, and then multiply by your negative 2 and add 8. So let's go ahead and stick with factored form and multiplying it out instead. So we've got negative 2 parentheses x plus 5 parentheses x plus 1. My recommendation is to save the negative 2 for the end, and so let's go ahead and start by multiplying out your 2 parentheses. So x multiplied by x is x squared, x multiplied by 1 is a positive 1x, 5 multiplied by x is 5x, and 5 multiplied by 1 is 5. Now I'm going to keep all of that in parentheses because we still have not yet multiplied by the negative 2, which I need to make some room for, in front of that expression. Again, I would go ahead and continue to simplify everything inside the parentheses first, so x squared plus 6x plus 5, and now we should be able to go ahead and distribute the negative 2. So negative 2 multiplied with x is negative 2x squared. Negative 2 multiplied with 6 is negative 12x. And then negative 2 multiplied with 5 is negative 10. So our standard form is y is equal to negative 2x squared minus 12x minus 10. Something you can do if you'd like to check your work, remember that in standard form, this last number, the c value should be your y-intercept, and so it should match what we have right here. And in fact, negative 10 does match negative 10, so we should be good to go. In addition, we could have done that on number 5. In standard form, we ended up with 8 as our constant. And let's see, we ended up with negative 8 as our y-intercept here. So let's go ahead and see what messed up, because obviously we got the wrong answer here. So let's figure out what went wrong. And so standard form, y equals x plus 4 multiplied by x should have been a minus 2. And if you caught that, great work. Good thing you were paying attention. If you didn't, you missed it. Try to get it next time. But let's go ahead and change that to what it needs to be, so x minus 2. What that means is a couple of things. We should have had a minus 2x and then a minus 8 at the end. So let's get both of those fixed. So again, that's a minus 2x minus 8. So that's actually going to change our answer a little bit. So that should have been a minus 2x plus 4x is going to be a positive 2x, and then the minus 8 at the end. Now our constant does in fact match what we had in our equation, and now we should be good to go. All right, guys, that is it for this section of the notes. In the next section, we will continue to use our graphing calculator to solve some systems of nonlinear equations, as well as to do some application problems. Until then, have a great rest of your day.